Hello students, welcome to video session. Let's learn something new today. Before going to today's session, just I'll remind what we have learned in the previous session. In the previous class, we have understood about Poisson's ratio and also stress strain diagram for different materials, that is ductile and brittle materials. Well, in today's class, let us deal with the unit conversion. Students, this unit conversion is very important topic since you come across this conversion in each and every problematic subjects. So that's why it's very important. So this is what the unit conversion is. First, let us see how to convert different dimensions, different parameters step by step. First, I'll deal with the unit conversion of length. Students, before going to the topic, with your animations will clearly explain you, will clearly tell you the units are mm and Newton. So in my subject, that is in strength of materials, I will keep units in mm, that is dimensions like length, area, different parameters. So in mm, length is for mm and area for mm square. Whereas in case of force, I will keep it Newton. So that is what my requirement. Okay. So first let us deal with the unit conversion of length. So first I'll take an example of a 5 meter. Length is 5 meter. First just understand whether unit conversion is required or not. Students, one thing is sure, in each and every problems, unit conversion is not mandatory. First, you need to understand whether unit conversion need to be done or not, whether it is necessary or not. So as I said, I require units in mm, but the given question as in terms of meter. So that is why I need to convert. So how to convert? Very simple. Length, I will take it as a L. Length is nothing but L. I'll put equal symbol as it is, and I'll put 5 as it is. In place of meter, I will put 1000 mm because 1 meter is equals to 1000 mm. So multiplication symbol, meter is nothing but 1000 mm. On multiplication, I get length is equals to 5000 mm. It's very simple. So I'll take one more example. So the length is equals to 7 meter. So don't go for blindly for conversion. First check whether it is necessary or not. So since the given question is in meter, but I require units in mm. So that is why I need to go for the conversion. So write L in place of length, then equal put as it is, then write 7 as it is, then multiplication symbol, then in place of meter, I will write 1000 mm because 1 meter is nothing but 1000 mm. On multiplication, I get L equals to 7000 mm. I'll take one more example. In this case, length is 10 meter. Students, you can pause the video and you can try on your own. Since I have explained it two conversions with examples, so you can go for a third one. So length L is equals to 10 into 1000 mm, that becomes 10,000 mm. And the next question is, just I'll move this window right here. Okay. Next question is length is equals to 7 mm. Students, as I said, you should never go for unit conversion blindly. First, you think whether unit conversion is necessary or not. In the given question, the units are in mm and I require mm. So there is no need of a conversion. Keep as it is. Okay, this is what the conversion of a length. Okay, friends. Now let's deal with another conversion, that is area, another parameter. So let's take an example. Area is equals to 5 meters square. Students, the units are in meter square, but I require in mm square. So there is a need of a conversion. So in place of area, I will write it as A, then put equal symbol as it is, then I will write 5 as it is, then multiplication symbol, because there is nothing in between 5 and a meter square, so multiplication symbol. In place of meter, I'll put 1000 mm, because 1 meter is nothing but 1000 mm. Since a meter has a square, so I need to put square for 1000 mm. That is why I'll put whole bracket and square, that nothing but whole square. In the next step, I'll try to remove the square. I'll try to remove the brackets. If I remove the brackets, then the square will be for both 1000 and mm. So I'll write 1000 square and mm square. Then on calculation, the 1000 square is written as 1,000,000 mm square. Finally, the final answer is A equals to 5,000,000 mm square. This is your final answer. Okay, let me take one more example. Area is equals to 7 meters square. So it is in meter, so I require in mm square. So what I'll do, put A is equals to 7 as it is, multiplication symbol. In place of meter, I'll put 1000 mm. Since a meter has a square, so I need to put square for 1000 mm. That is why whole square. After this step, I need to remove the brackets. If I remove the brackets, then square will be for 1000 as for even for mm also. That is why it becomes A equals to 7 into 1000 square mm square. On small simplification, I'll get the final answer. 7 into 1000 square. With the help of a calculator, you can calculate the 1000 square. It becomes 1,000,000 mm square. And final answer will be A equals to 7,000,000 mm square. It's very simple. So students, this is what another example for area equals to 10 meters square. So you can solve it very easily. So A is equals to 10 into 1000 whole square, 1000 mm whole square. A equals to 10 into 1000 square mm square. A equals to, this is your final answer. Students, next the fourth question is area equals to 7, area equals to 7 mm square. Students, now the question is itself in mm. I need it is mm square, so there is no need of a. Okay, students, I think this unit conversion is very clear to you. And now let's move on to the next set of unit conversion, that is force. Here, the very important parameters in force are kilo, mega, and giga. Kilo is nothing but 10 power 3, mega is nothing but 10 power 6, giga is nothing but 10 power 9. So let's see the questions one by one. The force or load both are same. The force or load is equals to 5 kilonewton. Students, as I said, the unit for force I require is Newton, but the given question has kilonewton. So there is a need of conversion. So how to do the conversion? Okay, in place of force or load, I'll write it as a P, because I will take a P for load or force. P is equals to, write 5 as it is, and in between 5 and kilo there is nothing, so I put a multiplication symbol. Kilo is nothing but 10 power 3, put 10 power 3 in place of kilo, and write Newton as it is. That's it. I'll not go for any further simplification. Okay, I'll take another example. Force or load equals to 10 kilonewton. So there's a need of a conversion since there is a kilonewton. So write P as it is, in P in place of force or load, and equal as it is, then 10 as it is, and multiplication symbol. Kilo, in place of kilo, I'll write 10 power 3, and then I'll place Newton as it is. Okay, I'll take another example. The force or load equals to 100 kilonewton. In place of force or load, I'll write P equal as it is, 100 as it is, multiplication symbol. In place of kilo, I'll write 10 power 3, and I'll write Newton as it is. Students, in the third example, in the next example, the force or load is equals to 100 Newton. Students, you need to be very careful here. There is no need of conversion. because the question is itself in a Newton. So there is no need of a conversion. Okay. So next example is force or load equals to 5 meganewton. Meganewton. So in place of force or load, write P equal as it is 5 multiplication symbol, and mega is nothing but 10 power 6 Newton as it is. Very simple. Next example is force or load equals to 10 meganewton. Force or load is nothing but P is equals to symbol and 10 as it is. In between 10 and mega there is nothing. So I'll put multiplication symbol. Then mega is nothing but 10 power 6. Then Newton as it is. Next, force or load equals to 100 meganewton. So you can solve it very easily. Next is force or load equals to 100 Newton. Since it is in Newton, so there is no need of a conversion. Now let's deal with the giga. So the given question is force or load equals to 5 giganewton. So I'll write P in place of force or load is equals to 5. In between 5 and giga, there is nothing. So I'll put a multiplication symbol. Giga is nothing but 10 power 9. And I'll write Newton as it is. I'll take one more example. Force or load equals to 10 giganewton. So write P for load equal as it is, 10 as it is. In between 10 and giga, there is nothing. So I'll put a multiplication symbol. Giga is nothing but 10 power 9 and Newton as it is. I'll take one more example. Force or load equals to 100 giganewton. P in place of load equal as it is 100 into 10 power 9 Newton. So this is another example. So it's already in Newton. So there is no need of conversion. Students, I think it's very clear. These are unit conversions of force. Now let's deal with the, now let's move on to another set of unit conversion, that is stress. One of the very important concept. Same kilo is nothing but 10 power 3, mega is 10 power 6, giga is 10 power 9. One more very interesting and important conversion is Pascal, where term is Pascal. It is written in terms of PA. It is written as PA and it is Newton per meter square. Students, it's very important. You need to remember Pascal is nothing but Newton per meter square. Students, very important one, because once you solve the problems, so you will repeatedly see this word Pascal. Majorly what students do a mistake is, in place of Pascal, you will put Newton per mm square instead of Pascal. Instead of writing Newton per meter square, you will write Newton per mm square. It's a mistake. It's totally a blender. It's a mistake. So keep in your mind that Pascal is nothing but Newton per meter square. Newton per meter square. Okay, let's solve one example. Friends, it's very important one. It's very important one. Just observe this. F is equals to 5 kilopascal. F is nothing but stress. Here, I'll take F as a stress. It should be a small f, but I have it in capital letter. It's not a problem. F is nothing but a stress. F equals to 5 kilopascal. So write F as it is and equal symbol as it is, 5 as it is. In between 5 and kilo, there is nothing. So I'll put a multiplication symbol. And in place of kilo, I'll put 10 power 3. Now, Pascal is nothing but Newton per meter square. So I'll write Newton per meter square. Students, is it clear? It's very simple. So I'll explain you once again. So I'll write F as it is, equal as it is, put 5 as it is. In between 5 and kilo, there is nothing. So put multiplication symbol. In place of kilo, I'll write 10 power 3. Pascal is nothing but Newton per meter square. I'll write Newton per meter square. Students, once you carefully observe the second step, there is meter square. There is a meter square. So, but I require in terms of mm. So again, there is a need of a conversion. So I'll go for unit conversion. Just carefully observe how I'll proceed with the next step. I'll write F as it is, equal as it is, 5 as it is, multiplication symbol as it is. After multiplication symbol, I have 10 power 3. I'll write 10 power 3 as it is. After 10 power 3, I have Newton. I'll write Newton as it is. After Newton, I have division symbol slash. There's a division symbol. So I'll put a division symbol, division. And after division, there is a meter. In place of meter, I'll write 1000 mm. For meter, I have a square, so I'll put a square for 1000 mm with the help of a brackets. It's very simple. Now I'll go for further simplification. F is equals to 5 into 10 power 3 as it is, and I'll write Newton as it is, divided by as it is. I'll remove the brackets. Once I remove the brackets, then the square will be for both 1000 and mm. So that is why I'll write 1000 square and mm square. Next, what I'll do is I will take a Newton per mm square separately. I'll separate it. So F is equals to 5 into 10 power 3 as it is, divided by 1000 square. Then I will write this once again, yes, this Newton per mm square. I'll write it separately. So this is what I'll do. So this becomes Newton per mm square. So it's very simple. And you can go ahead with the simplification with the help of your scientific calculator. So I'll wind up to here, and you can go ahead with the further simplification with the help of your scientific calculator. I'll take another example. Just listen very carefully. So F is equals to 10 kilopascal. So I'll write F as it is, then equal as it is, 10 as it is. In between 10 and kilo, there is nothing. So I'll put a multiplication symbol. In place of kilo, I'll put a 10 power 3. And a Pascal is nothing but Newton per meter square. I'll write it as a Newton per meter square. Once I clearly observe, I have meter square, but I need in terms of mm. So there is a need of a conversion again. So write F as it is, equal, then 10 into 10 power 3. After 10 power 3, there is Newton. Write Newton as it is. After Newton, I have division symbol. Put a division symbol, I mean slash. Then in place of meter, I'll put 1000 mm. So meter has a square, so I need to put a square for 1000 mm with the help of brackets. What I'll do in the next step, just I will remove the brackets. So F is equals to 10 into 10 power 3 Newton divided by 1000 square mm square. And in the next step, what I'll do in the next step, just I will separate Newton per mm square from simplified part. F is equals to 10 into 10 power 3 divided by 1000 square. Separately, I'll write it as Newton per mm square. This is what the conversion is. So this is an example. You can solve it. So F equals to 7 kilopascal. So F is equals to 7 into 10 power 3 Newton per meter square. Same as it is 7 into 10 power 3 Newton divided by 1000 mm whole square. On simplification, I'll get this answer. So this is the answer for your question. Next example, F is equals to 2 kilopascal, and the same thing, students. What we have done, you need to do with this question. You need to deal with this question. You take it as a homework, then you are supposed to do that question. Okay, is it clear? Okay, done. Now, let's deal with the megapascal. In the previous slide, we have done with kilopascal. Now let's deal with the megapascal. Same thing, the concept is same. Instead of kilo, here we have mega. That's it. There is nothing difference. So F as it is, equal as it is, 5 as it is. In between 5 and mega, there is nothing. So multiplication symbol. In place of mega, you put 10 power 6. Pascal is nothing but Newton per meter square. Since we have meter, so I need to go for another conversion. F is equals to 5 into 10 power 6 Newton divided by, in place of meter, and I will put 1000 mm whole square. After removing the brackets, I'll get this answer, 1000 square mm square. Now I'll separate Newton per mm square from the simplified part. F is equals to 5 into 10 power 6 divided by 1000 square Newton per mm square. This is what I'll do is. The next part, F is equals to 7 megapascal. So F as it is, equal as it is 7. In between 7 and mega, there is nothing. So I'll put a multiplication symbol. In place of mega, I'll write 10 power 6. In place of Pascal, I'll put Newton per meter square. So then F is equals to 7 into 10 power 6. Newton as it is, divided by symbol. In place of meter, I'll put 1000 mm and then square. Again, I'll remove the brackets. Then the simplified part becomes this line like this. Then finally, I'll separate Newton per mm square from the simplified part. This is the answer. Students, this is a question. Just try this question. Take some time, and you can try on your own. Anyhow, I'll give the solution. You can cross check with this. Just what you are supposed to do is you need to pause the video and you can solve the question. Once the solving is done, you can cross check your answer with my answer. So this is the final answer. So you are supposed to do on your own. Next, let's deal with the gigapascal. So I'll give one example. F is equals to 5 gigapascal is the stress. So F equals to 5 gigapascal. So how to do this? F as it is, equal as it is, 5 as it is. In between 5 and giga, there is nothing. So I'll put a multiplication symbol. Giga is nothing but 10 power 9. Pascal is nothing but Newton per meter square. So again, you observe the second step. There is a meter. So there is a need of conversion. So F as it is, equal as it is, 5 into 10 power 9. After 10 power 9, I have a Newton. Put Newton as it is. After Newton, I have a slash. So put a slash. After slash, I have a meter square. In place of meter, I'll put 1000 mm. Then I'll put a square. So on simplification, that is on removing the brackets, I'll get 1000 square mm square. Now I'll separate Newton per mm square from the simplified part. So this is what I'll do, Newton per mm square. Friends, it's same. There is nothing difference from kilo, mega, and giga. Everything is same. Just you need to understand the concept. In place of kilo, you need to put 10 power 3. In place of mega, 10 power 6. In place of giga, 10 power 9. In place of Pascal, you need to put Newton per meter square. That's it. It's very simple. So next, F equals to 7 gigapascal. So F is equals to 7 into 10 power 9. Pascal is nothing but Newton per meter square. So F is equals to 7 into 10 power 9 Newton divided by 1000 square, 1000 mm whole square. On removing the brackets, the step will become simplified, but will become 1000 square mm square. This is your answer. Students, you try on your own. F equals to 2 gigapascal. Just you pause your video and keep solving this question. Anyhow, I'll give a solution for this question. This is a solution, and definitely you can go ahead with the further simplification. Definitely we are supposed to do that final simplification, but we require scientific calculator. So I'll leave up to here. So this is what unit conversions is. Students, this is all about the unit conversions. In the next class, I'll deal with the problems. Okay, this is for today's class. Then let's meet on the tomorrow's class.